Alright guys, today's goal is exponential functions. So they want us to simplify this. So see how the base is the same? So you add the exponent. So this is going to be, so you get 2 to the 2x minus 1. Here it wants you to evaluate for those three different ones. So if I say 3, so f of negative 2 equals 3 to the negative 2. You get 1 over 3 squared, because remember you make it positive, so it would be 1/9. F of 0 equals 3 to the 0. 1. Anything 0 powers 1. F of 1 equals 3 to the first equals 3. Just make sure you can use your calculator and that you don't give me decimals, you give me fractions. Okay? So same thing here. So watch what I do. This is 3 to the negative x, which is just 1 over 3 to the x. Or you can leave it. We'll just leave it. So all you have to do, 3 to the negative 2, so it's going to be 9. 3 to the negative 0, so it's still 1. 3 to the negative 1, so it's 1/3. Okay? Let's keep going. So this time we want to graph the function. Well, first thing we need to do, so I want to talk about something actually. So f of x equals a times b to the x minus h plus k. If you've had me before, you've seen this. Okay, now so y equals k is always the horizontal asymptote. So see how there is no plus k here, so that means at the line y equals 0, you draw a horizontal asymptote. And what that means is it's either going to be always above it or always below it. It will never ever cross it or touch it. Okay? So what we want to do is plug these points in and calculate. Well, 2 to the 0 is 1. 2 to the negative 1, 1/2. That'd be 2. 1/4. And 4. So if I graph 0, 1, and then 1, 1/2, negative 1, 2, I'm going to go to negative 2, 4, and 2, 1/4, so it's going to look like this. Plug it into your calculator to check, though, for yourself. Alright, let's look at some more. Alright, so the word problems here. It says cesium-137 is a man-made radioactive element with a half-life, okay? We'll talk about that in a minute, of 30 years. A large amount of cesium-137 was introduced into an atmosphere by nuclear weapons, testing in the 1950s and 1960s. By now, much of that substance has decayed. Most of the current cesium-137 currently in the atmosphere is from nuclear accidents like those in Chernobyl in the Ukraine and Fukushima in Japan. Cesium-137 is one of the most dangerous substances released by those events. After T years, 16 grams of cesium-137 decays to a mass in Y grams, given by the equation Y equals 16, 1/2 T to the 3. Okay, so when it said half-life, that meant the base was the half-life. 16 is the initial amount, and the time is there, but you got to divide it by 30 because that's how many years it takes to get rid of half of it. So like if it's only been 1 year, it's been 1/30. And yes, T is always greater than 0 because it's time. Okay? So this was 16, half, 30, or time of half-life is 30 years. So the time of decay we're looking at is 80. So you go y equals 16 times 1/2 to the 80 divided by 30, and then you plug it into your calculator and hit enter. And you would say that there is approximately 2.52 grams left. Okay? Alright, let's take a look at one more. Alright, so it says find the amount in the account for per year compounding and continuous compounding. Okay? So we have two equations to look at. there's this, and then there's this. When you see PERT, that's for the continuous part. When you see this one, you have to figure out n. N is the number of times per year. It says per year, so n is 1 here. So for this one, we're really just dealing with the original equation, 1 plus r to the t. So for part A here, you're going to have A equals, they're saying quarterly, 4 times per year. So we're going to be, that's my fault, we're going to be using this one, but still, we still have A equals $100 times 1 plus 0.07 divided by 4 to the 4 times 15. Put into your calculator, hit enter. You would have $283.18. Okay? And then part B, they wanted compounding continuously. So continuously, you would use this. A equals, what was it, 100 e to the 0.07 times 15. So 100 e to the 0.07 times 15. And this one would be $285.77. All right, we'll see you guys in class.